All right, this next section goes to something beyond E, but it still deals with logarithms. And when I use logarithms here, it doesn't really make any difference what the base is. If I have ln like I have here in this statement right there, it could also be log of n. It can be log base 10. It really doesn't make any difference as long as your calculator has a system that uses it. So we generally stick to log or ln, but they're both logarithms. And again, please remember, the word logarithm means exponent of a certain base. Log is a base 10. ln is a base e. Okay? So there's some definitions here. This is definition of exponential function to base a. A means any a number greater than or equal to 1. Or not equal to, greater than 1. So if a is a positive real number, a does not equal 1. And x is any real number, then the exponential function to the base a is denoted by log base a for x, and is defined as log base a of x equals 1 over natural log of a times the natural log of x. Okay, blah, 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 right? Well, we're going to have some practical application of this, as you can see. The definition of logarithmic function of definition of logarithmic function to base a is, again, if a is a positive, and I said, I misspoke, I didn't say any greater than or equal to 1 or greater than 1. It's any positive real number except for using the number 1. And x is any positive real number, then the logarithmic function to the base a is denoted by log base a of x, and is defined as log base a of x equals 1 over the natural log of a times the natural log of x, which is pretty much what we described in the previous one. This is where the rubber hits the road, are the properties of inverse functions. So we can say y equals a to the x if and only if. Now this is really important here. This will help you understand, I hope, especially when you start doing the problems. Okay, so this a is being taken to the x power. So that means x is its exponent, and a is the base of that exponent. So when you take the log of both sides, that means then that your logarithm, which means your exponent of a for y, is going to be that exponent x. This is just written two different ways. Same thing. Base a, exponent, logarithm, x. Result, y. A to the log of base a of x is x, because the a's, as this is saying, the exponent of the base a is x here, so that just becomes x. And then log base a of a to the x is x, because by definition, logarithm means exponent of the base a. And that's exactly what it's saying right there. All right, so let's take a look at some problems. We're going to be looking at page 366 here. We're looking at some odd number examples here, and this is just a matter of now mathematical manipulation to come up with our answers here. Log base 3, so base is 3. The log or exponent is -1. And x is your result, equals x, and 3 to the -1 is 1/3. That's simple. This right here, the base is 2. The logarithm or the exponent is -4, and that's going to equal the result, x. And 2 to the -4 power is 1 over 16, or if you type it out in your calculator, 0.0625. Number 19, we're given an algebra problem involving logarithms, but no big deal. Why? Because it says that the exponent, the logarithm, the exponent is x squared minus x of base 5. So 5 to the x squared minus x equals 25. Well, what are we going to do with that? Well, we know 25 is 5 to the second power, and now we know that since these are equal, their exponents are equal. So x squared minus x equals 2, which is what I have there. So we just bring the 2 over by subtracting 2, and then we factor it. X minus 2x plus 1 equals 0. Set them both equal to 0. X equals positive 2. X equals -1. This is not difficult stuff. You just have to keep thinking what the word exponent means and what the word base means. Next one, number 21. 3 to the 2x power equals 75. Well, what are we going to do about that? Well, we need to get rid of that exponent. Bring it out. So what we do is we take the log of both sides. Now I use natural log. You can use the log. It will give you the same answer. So this is saying the log of 3 to the x power. And since we have a power of a power, this is an exponent here, this is an exponent here. So the two exponents are going to multiply together. So 2x times the log of 3 equals natural log of 75. Divide both sides by natural log of 3. We get 2x equals natural log of 75 over natural log of 3. Get the x by itself by dividing by 2. So putting that in the denominator, type it all out. Your answer is 1.96. Round it off. Alright, this one you just have to simplify what's inside the parenthesis and go from there. If you punch that out in your calculator, you get 1.075. The exponent is still to the 12t power, and that equals 3. So we got, again, anytime you have an exponent in with a variable in it, you have to take the log on both sides. Again, natural log, common log makes no difference. And so that's going to move the 12t out here in front, times the exponent natural log of 1.075 equals natural log of 3. So we just divide both sides by 12 and natural log of 1.075. Divide that out in your calculator. Make sure you hit division for this. And you get 12.3 for your answer. Number 27, we're given log base 2 of x minus 1 equals 5. Well, if the log is base 2, then I'm going to take 2 as to the power of these right here to get rid of that nonsense there. And this is saying the exponent of 2 is 5. That will give you x minus 1. So that means then the exponent of the quantity that says exponent will give you that exponent, x minus 1 equals 32. Add 1, x equals 33. This is so easy. Oh my gosh, this is crazy. Last one. There's a number of ways that we could have done this one. This is the way I prefer to do it. I like getting rid of the 3, log 3. So I take 3 here on both sides. It gives me x squared equals approximately 140. 3 to the 4.5 power is 140. You take the square root of that, which means you're going to get two answers, a positive and negative, and the answer is 11.8. That's all there is to it. Practice on this makes you more confident on this. The more confident you get on this, the more you realize this is a simple assignment. All right, your homework. Practice problems. Page 366, 18 through 30 even. Do not do number 24. Have fun.